Hi, this is Tanawan. In this video, my friend and I will talk about Lab 3 Part 2. The big picture of Lab 3 Part 2 is making automatic trading simulator. In the simulator, we allow user to specify stock name and amount they want to trade in specific period of time in the past. We only allow period in the past because we want to be able to perform evaluation of price prediction. After users give the trading period, we decided to use 1 year data before the specified period to train ARIMA model. After we get the predicted price from ARIMA model, we use it to calculate the three indicators, which are RSI, moving average crossover, and moving average convergent divergent. Then we build buy and sell algorithm. We then recorded buy and sell transactions to transactions table in MySQL and also calculate and store the profit loss and portfolio balance. Now let's look at the function that support our trading strategy. The first function is prep finance. For this function, we use YFinance API to get historical price data from Yahoo Finance. The inputs of this function are name of stock, start date, and end date of the data you want. The next function is extract all data from table SDF. We use this function to get data and convert them into data frame to be ready for analysis. The next three functions are functions to calculate three indicators. We decide to use three indicators to determine our decision to buy and sell, including calculate RSI, moving average crossover, and MACD. Now let's look at the calculate RSI function. RSI tells if stock is oversold or overbought. This function calculates the value of RSI, which is ranged from 0 to 100. When the number of RSI is high, reaching 70 or higher, it means that the stock is overbought. And if RSI is low, reaching 30 or lower, the stock is oversold. Next function is moving average crossover. Moving average crossover is a strategy that tells you when to buy or sell, depending on when the two moving average line cross each other. In practice, moving average of 12 and 26 days are famous for short-term trading, so we are using those two periods here. The strategy that we will use here is we buy when 12-day moving average cross above 26 days and sell when 12-day moving average cross below 26 days. The last indicator function is moving average convergent divergent or MACD. MACD is using the concept of exponential moving average or EMA. MACD line is calculated by subtracting the 26 period EMA from the 12 period EMA. The signal line is a 9 period EMA of the MACD line. When the MACD falls below the signal line, it is a bearish signal indicating that it may be time to sell. Conversely, when MACD line raises above the signal line, the signal is bullish, suggesting that the price of the asset might experience upward momentum. The next function is get prediction. The get prediction function requires stock name and trading period as input, and it will use rolling forecast technique in ARIMA model to get predicted stock price. After it gives the stock price, MSE, MAE, or MSE are also calculated to see the evaluation.
Now let's see buy and sell signal logic. We are using three indicators to get the signal. First, we are generating buy and sell signals for each indicator based on a set of conditions. For RSI indicator, if the value is low compared to 5 values before and after, then we will give the buy signal. And if the value is high compared to the 5 values before and after, then we are giving the sell signal. And if it is not low or high, then we are giving a hold signal. For the EMA indicator, if short period crosses above long period, then we are giving a buy signal. And if long period crosses above short period, then we are giving it a sell signal. For the MACD indicator, we define buy and sell signals similar to EMA signals. Once we convert all indicator values to buy, sell, and hold signals, we are comparing the three indicators to get one final signal. After getting final signals, we are eliminating the dates which have hold signals because we only want to store real transactions, and also making sure that sequence of transactions to be sell after buy. When we are comparing the three indicators, we are giving more weight to buy and sell signals over hold signals. For example, when we have buy, hold and hold signals, we are considering buy as the final signal. We implemented a simple moving average algorithm. For that, we used 1 year stock price data of 4 companies, including Apple, Microsoft, KLIC, and LPX. These are the outputs generated by the moving average algorithm.
Now let's take a look at how we updated our database. Here we updated the create database.py file. We added a new table to the lab3 database, which is transactions table. You can see from line number 52. Here we have the columns user, transaction date, stock symbol, unit price, which is the stock price, action to sell or buy, shares per transaction is the number of shares the action must be done on, number of shares balance, which is the shares left after the action, investment value, the value of the stocks left after the action, profit or loss, the amount either gained or lost after the action is taken, portfolio balance, the amount left after the action. As a primary key, we are using user, transaction date, stock symbol, and action. We have also updated the manage portfolio.py script. Here for the existing options, we have added an additional option, trading. In this trading option, user gets to give his username and enter his stock with which he wants to trade, and also the initial investment value and the date range. And using all of these values, we get 1 year data, which is just before this date range, and store it into the stocks table. And we use the get prediction function from the utils.py, which accesses this stocks tables information and gives out a data frame which contains dates on which the trading has to be done, and the action to be done on each of the date, and the stock price for each of those dates. Now we iterate to this data frame and get those dates. We do the transaction on those dates, get the unit price, and perform this particular action, either buy or sell, and get all the different column values for one record of the transaction table, like profit, loss, portfolio balance, using the appropriate formulae, and finally insert the record into the transaction table. After inserting all the transactions into the transaction table, we print profit, loss, investment value, and portfolio balance for the user. Now let's try to run our scripts. First, let's create the database. Using create database.py, we can see that it says the tables are created properly. Let's check it out. Yeah, we see lab3 database. And let us look at the tables, and we see transactions. We can see all the columns here in the transaction table. Now let us try to do the trading. That is nothing but the mock trading environment using the manage portfolio.py. Okay, no, so let's select option 3, which is trading. Let's give our username and a stock, maybe Apple, investment $1 million. Let's try to trade for maybe 4 months. 0, 5, 0. Yeah. Okay. Okay, we can see the results here. We can see that there is a profit of $363,000 and balance is this. Okay, let's try to look at the database, in particular the transactions. Okay, here let us try to understand. Okay, here we can see that only these dates from the 4 months were selected by our hybrid model to do the actions of buying and selling. And you can see that the portfolio balance has been being changed. As we buy the stocks, it's being reduced, and as we sell and gain some profit, we are having an increment in the balance. And this is our final balance, which is also printed here by our Python script. Okay, so that's our lab 3 part 2. Thank you.